I have a question for you. How much TV did you watch today? The reason I'm asking this is anytime you ask Gemini a question, that is equivalent to watching 9 seconds of TV. If I look at my day and my usage of AI this morning, I have watched as much as 10 minutes of TV already, and it's not even 9 o'clock yet. So the promises of AI are virtually unlimited. We discover new use cases, broader and bigger use cases for AI every day. But building of the AI infrastructure is not unlimited. If you look at how fast the AI infrastructure is coming online, it is the pace of that is not set by how much compute you have. The pace of that is not set by how much capital you have. The pace of that is not set by how much real estate you can get, but the pace is set by how quickly you can power. So it's the power management and power delivery infrastructure that is setting the pace of AI build. So today, humanity's progress, the speed of humanity's progress is set by how fast we can power the data centers. All right. So we have an observation and a framework to share with you in this regard. First, the observation. We have observed that if the current power management stack, so from the chip to the server to the rack, all the way to the data center, it is mismatched with the AI workloads. The power management stack is too slow and it's not, and the sensing and intelligence is not granular enough. But the AI workloads can fluctuate. They fluctuate from 10% to 90% in a matter of nanoseconds. Now, this mismatch in speed and granularity causes a lot of problems in the AI infrastructure today. Now, industry deals with it in a couple different ways. First, you end up overmargining the chip. So you end up adding as much as 20 to 30% margin to your chip in order to account for these fluctuations and variations. The second is you end up overbuilding the entire data center. So the data center is over-provisioned. So if you're building 1 gigawatt data center, you may be adding as much as another 20%. So you'll be building a 1.2 gigawatt data center in order to account for these fluctuations. This is beyond your maximum load. All right. So if you're expecting 1 gigawatt max peak performance and load, you're building extra margin in order to account for these fluctuations. So there's a ton of innovation going on in order to help this problem. So several of our friends are working on faster voltage regulators, which helps the speed a little bit. Also, there's direct conversion from 800 volts all the way down to less than 6 volts in order to avoid I squared R losses, which is great. However, fundamentally, if you distill it down to first principles, what we believe needs to happen is that the power management infrastructure, speed, granularity, and intelligence needs to be caught up with the AI workloads in terms of speed, granularity, and intelligence. All right. So there's a mismatch. Now let's see what we can do together as an industry for this. Next time, we will share our 4 Ps of well-architected power management stack infrastructure, and that will look at what a well-architected power stack looks like from the core to the chip to the server and all the way up to the data center level. Thank you.